Hello my dear students, I warmly welcome you to CR Digital Classes. So now in this lecture, we are going to discussing one of the important topic from this third unit. So first of all, see the question. First question is define angle of the rotation and the define scale factor for the matrix A minus B BA. Okay, so this is the first question. For this question, we have to define the angle of rotation. Mathematical, we can denote it by phi. So second definition is scale factor. So it is denoted by small r for the 2 by 2 matrices. Next, the second question is prove that A plus or minus Bi, A plus or minus Bi are the eigenvalues of a 2 by 2 matrices of the form A minus B, B plus A with corresponding eigenvectors 1 comma minus I and 1 comma plus I, where small a comma b are real numbers. Okay, that is the second question. Here you can observe that A plus or minus Bi are the complex eigenvalue for the given 2 by 2 matrices capital A. For that complex eigenvalues, we have to show that the corresponding eigenvectors are 1 minus I and 1 plus I. So third question is find the eigenvalues of the given matrix capital A is equal to, so root 3 minus 1, 1 root 3, and give the example of angle of rotation and find the value of the scale factor. Okay, in this lecture we are going to discussing three problems. Okay, so first problem we are going to discussing about the definitions. In the second problem we are going to show that the complex eigenvectors, and the third problem we are going to discussing the scale factor and angle of rotation. So first of all, we are going to discussing the definition of angle of rotation. If capital A is equal to A minus B, BA is a 2 by 2 matrix where A comma B are real numbers. So okay, whenever you get capital A, randomly we can take capital A as A, B, C, D in this format, regular notation for that 2 by 2 matrices. But in our definition, especially we are denoting that capital A as the particular form of A minus B, BA. A minus B, BA. Okay, not in this format. So whenever you take capital A is equal to A minus B, BA. Okay, these types of matrices. Okay, and not both values 0. Then the eigenvalues of capital A are both values here. In this matrix we have only two non-zero values. Okay, those are small a and small b. Both values belongs to real numbers. Okay, except to 0. A comma b not is equal to 0. Then we can define the eigenvalues of capital A are lambda. You know very well the usual notation of eigenvalue is lambda. Lambda is equal to A plus or minus B into I. Then capital A can be written as, okay, so capital A equal to in this format A into minus B, BA. That is the original value. For that original value, we are multiplying. We are multiplying and dividing with the scale factor small r, and also we are dividing with a 2 by 2 identity matrix. You can see here clearly where capital I suffix 2 is equal to 1001 is the 2 by 2 identity matrix. Now substitute the corresponding values from the given data. So capital A equal to small r into, okay, so you know very well capital I2 value 1001, and this 1 by r value you can multiply with capital A. So then you will get A by small r minus B by small r minus B by r and A by r. So this is the resultant matrix after dividing with scale factor small r. So therefore capital A is equal to, if you multiply this identity matrix with the vector, so therefore R0 0 R, that is the resultant diagonal matrix, and this value small a by r is there, that value we can write cos phi. Okay, and this minus b by r is there, that value we can write minus sin phi. So here plus b by r is there, that value we can write plus sin phi, and small a by r is there, we can write cos phi. Why? Because whenever you draw a 2D dimensional diagram for these values, then this small a by r minus b by r the values for the sin phi and cos phi. You know very well the formula for the sin theta and cos theta. In place of theta, here we are taking the angle of rotation in place of regular theta. So here we are taking that the angle of rotation, that especially angle of rotation we can denoted by phi. Okay, so you can see here, then the angle between the positive x-axis and the real segment from 0 to 0 through a comma b is called the angle phi of the rotation, or the angle phi of the rotation, or the argument of lambda is equal to a plus bi. So okay, clearly you can see from the diagram, mama. So this is the positive x-axis, okay, and this one is the, you can imagine it is a y-axis. The angle between them we can denote with phi. That angle between the positive x-axis and the real segment, the ray or segment. Ray is nothing but which has two end points, okay. So this one is, you can call it as a ray, okay, from origin 0, 0 to the point a comma b, that is called segment, okay. So from 0, 0 through a comma b, that angle between those two lines is called the angle phi of the rotation, or else the other name is the argument of the eigenvalue lambda is equal to a plus bi, okay. So it is denoted by phi, and which is shown in the diagram as we have discussed it now. So that is the definition regarding the angle of rotation. So basically in intermediate level we can discuss this angle of rotation as a sin theta, cos theta in that format. Now we are going to discussing in the same format sin phi. You know very well from this diagram, clearly you can observe that. So whenever you take this theta as phi, you can make the formula for the sin theta. You know very well sin theta formula, opposite sign by hypotenuse. So therefore here opposite sign is b, hypotenuse means small r, okay. So for the cos theta formula, that is cos phi, it is adjacent by hypotenuse. So therefore small a by small r. So in the previous matrix only, in place of b by r, a by r, so we have written cos phi minus sin phi. So in that format only, a by r minus b by r, so we have written cos phi sin phi in that purpose only. So therefore whenever we are talking about the angle of rotation, we can take the values in that format. So that is the definition regarding the angle of the rotation. The next definition is the scale factor, okay. The magnitude value or absolute value of the complex eigenvalue of capital A is equal to a minus b ba is called the scale factor. So here you know the magnitude value or absolute value. Magnitude is nothing but the perfect value. Absolute value is nothing but the modulus value, okay. So whenever you take a complex eigenvalue, for example lambda is equal to a plus ib, to find its real value, we can apply the modulus on both sides, okay. So therefore it is denoted by small r and defined as small r is equal to mod lambda. You know very well where lambda is equal to the complex eigenvalue a plus bi. So small r is equal to mod of a plus r minus bi. You know very well the formula small r is equal to under root of a square plus b square, where a comma b are the any two real numbers. So in this format we can find the formula for the scale factor. So okay, so here you can see the diagram also clearly, positive x-axis and the segment from the origin to the point a comma b. So here small b indicates the height from the positive x-axis to that point a comma b, and here small r is there. Small r is equal to mod lambda. That small r is called only scale factor, okay. That small r is called length of the segment, okay. Length of that segment we can call it as a scale factor. So from the figure we can write sin phi is equal to b by r. Why? Because here theta is at origin, that is phi. Sin phi is equal to opposite sign by hypotenuse, and cos phi is equal to adjacent sign by hypotenuse. So therefore in that format we can write. Then to find the angle of rotation, whenever we got the values of sin phi and cos phi, to find the angle of the rotation phi, the formula is arc into tan b by a. That is the formula. Phi is equal to arc into tan b by a. You know very well the small b value and small a value also, simply you can substitute them in that formula, then you will get that the angle of the rotation. That is the first question regarding the definition. So now we are going to discuss in the second question. Given matrix is capital A is equal to A minus B BA, where A comma B are the two real numbers. Now to show that lambda is equal to A plus or minus BI are the eigenvalues of the given matrix capital A. Okay, so no need to examine the characteristic equation det of A minus lambda is equal to 0. Oftenly, whenever we are talking about that the eigenvalues and characteristic values, so it is very practice to take that the characteristic equation, that is det of A minus lambda is equal to 0. For this time, it is no need. So we are clearly mentioning that the need of characteristic is not useful here. Given vectors are x1 is equal to 1 comma minus I and x2 is equal to 1 comma plus I are the two vectors. From the definition of eigenvector, we can write A into x1 is equal to lambda 1 into x1 and A into x2 is equal to lambda 2 into x2. So first of all, consider with the first equation. Okay, A into x1 is equal to lambda 1 into x1. That is, so substitute the corresponding values, capital A value, and x1 is the first vector. Okay, 1 into minus I. That is at the column matrix. And you know very well, lambda 1 is the eigenvalue and x1 is the given value only. So apply the matrix multiplication for that vector and matrix. So then you will get resultant 2 by 2 matrices in that format. A plus bi, b minus ai is equal to lambda 1 into 1 into minus I. So therefore a plus bi. So you can take from this column. Okay. So therefore minus I common, then a plus bi. That is equal to lambda 1 into 1 minus I. RHS will be as it is. So from the first column in the LHS, we can take a plus bi value. Here we have a plus bi value and here we have a plus bi value. So you can take a plus bi value common. Then a plus bi into, if you take that a plus bi value common, then you will get that remaining values that are in a column matrix format, that is 1 minus I equal to lambda 1 into 1 minus I. Then here we have equality symbol. We can equate both matrices, corresponding values we can equating, comparing on both sides. So you will get that here eigenvector both are same. So then lambda 1 is equal to a plus bi. So this lambda 1 value is equal to this value a plus bi. So lambda 1 is equal to a plus bi is the first or one of the eigenvalue of the given matrix capital A. This lambda value a plus bi is applicable the given matrix capital A is in this format only, a minus b, b, a. So మీకు examination లో కూడా short answer purpose లో questions ఇదే format లోనే అడుగుతాడు. Capital A is equal to a minus b, b, a ఈ format లో ఒక matrix ఇచ్చి 2 by 2 matrix ఇచ్చి, సో వాటికి మీకు eigen values find out చేయండి అంటే, సో instead of doing all that regular process, characteristic equation apply చేసి det of a minus lambda i formula apply చేసి మనం simplify చేసి ఒక quadratic equation వచ్చేటట్టుగా మనం ఫామ్ చేస్తాం కదా. Instead of doing all that regular process, సో జస్ట్ అబ్జర్వ్ ద గివెన్ మ్యాట్రిక్స్. ఆ మ్యాట్రిక్స్ మనకు ఏ ఫార్మాట్ లో ఎగ్జిస్ట్ అవుతా ఉంది. సో మనకు యాంగిల్ ఆఫ్ రొటేషన్ ఫార్మాట్ లో ఎగ్జిస్ట్ అవుతా ఉంటే డైరెక్ట్లీ యూ కెన్ రైట్ ద ఫస్ట్ eigen వాల్యూ ఆఫ్ ద గివెన్ మ్యాట్రిక్స్ ఇస్ a ప్లస్ bi. అక్కడ ఏ బి వాల్యూస్ పర్టికులర్ గా మనకు మ్యాట్రిక్స్ లోనే మెన్షన్ చేసి ఉంటాడు. ఓకే, సో ఈ వాల్యూ మనకు తెలిసి ఉంటుంది, మైనస్ బి వాల్యూ కూడా మనకు మెన్షన్ చేసి ఉంటాడు కాబట్టి అదే వాల్యూస్ ని తీసుకొచ్చి సో లాంబ్డా 1 ఇస్ ఈక్వల్ టు a ప్లస్ bi అనే ఫార్ములా సబ్స్టిట్యూట్ చేసుకొని వాటి లోపల వాల్యూ సబ్స్టిట్యూట్ చేసుకుంటే యూ విల్ గెట్ ద ఫస్ట్ eigen వాల్యూ. నో నీడ్ టు డూ దట్ ఆల్ ద characteristic equation process whenever the matrix has in that format only, especially capital A is equal to a minus b, b a. Okay, next ఇక్కడ చూడండి, consider second case. ఇక్కడ whenever according to the definition of the eigenvector, so a into x2 is equal to lambda to x2. We are taking that x2 vector is a eigenvector. That's why only we are taking that equation. So ఎప్పుడైతే దాన్ని eigenvector అని తీసుకున్నామో, it has to satisfy the condition that eigenvalue, okay, corresponding eigenvalue. So substitute the corresponding values. So capital A minus b, ba, and x2 value is 1i equal to lambda 2 will be as it is and x2 value 1 plus i. So in LHS you can multiply both vectors. So then you will get one column matrix a minus bi and b plus ai. So it is equal to lambda 2 into 1i. So in LHS only, so in the second row you can take small I common. First row will be as it is a minus bi. In second row, if you take small I common, then you will get in this format, small I into a minus bi equal to lambda 2 into 1i. So in that matrix only, in the first column, we can take common a minus bi and a minus bi. So similar values we can take common, then you will get in this format, a minus bi into remaining values we can write in the column matrix format, 1i is equal to lambda 2 into 1i. So again here we are getting the same values in LHS and RHS. Those two same values are the x2 values only. Remaining values we can equating, lambda 2 is equal to a minus bi. Why? Because equality symbol is there. So by comparing on both sides, so we can get lambda 2 is equal to a minus bi is the another eigenvalue of capital A. A minus bi is the another eigenvalue of capital A. How we can say? Why? Because so already we have taken this formula, ax2 is equal to lambda 2 x2. ఈ ఫార్ములా తీసుకున్నాం. ఆ ఫార్ములా ఏంటి మనకు? eigen vector ఫార్ములా. eigen vector ఫార్ములా తీసుకొని మనకు ఒక కాన్స్టెంట్ వాల్యూ వచ్చింది అనుకో, డెఫినెట్ గా కాన్స్టెంట్ ఏమవుతుందంటే మనకు eigen వాల్యూ. ఓకే, eigen వాల్యూ. వై? బికాస్ eigen vectors always formed by the corresponding eigen value only. So therefore already మనకు ప్రీవియస్ గా lambda 1 is equal to a plus bi వచ్చింది. ఇప్పుడు మనకి ఏమొచ్చింది? lambda 2 is equal to a minus bi అని వచ్చింది. సో ఈ రెండింటిని మనం క్లబ్ చేసి రాసుకుంటే మనం ఏం రాస్తామంటే సింపుల్ గా lambda is equal to a plus or minus bi. Therefore lambda is equal to a plus or minus bi are the eigen values of capital A corresponding to 1 minus I and 1 plus I. That is the total explanation of the second problem. Okay, so next third problem. So given matrix is capital A is equal to root 3 minus 1 root 3. You can clearly observe that it is not a regular matrix amma. Meer problem lo chusukunnataithe previous ga unit 1 unit 2 lo kuda same 2 by 2 matrices unnai. So it is not like in that format. So it has some special property. We can compare with the angle of rotation matrix. Capital A is equal to A minus B BA. Only two elements ఏ ఉన్నాయి ఆ మ్యాట్రిక్స్ లో. ఆ టూ ఎలిమెంట్స్ లో రెండు ఈక్వల్ గా ఉన్నాయి అండ్ వాటి సింబల్ ఒకదానికి ఏమంటుంది? మైనస్ ఉంది. సో మీరు ఆ మ్యాట్రిక్స్ తోటి కంపేర్ చేసుకున్నారు అనుకోండి, ఇన్స్టెడ్ ఆఫ్ డూయింగ్ ఆల్ దట్ రెగ్యులర్ ప్రాసెస్ det of a minus lambda I equal to 0, so directly we can write here. You can observe clearly. So it is in the form of capital A is equal to a minus b BA. సో మనం చూడగానే అర్థమైపోతుంది ఇక్కడ ఓన్లీ మనకు రూట్ 3 అనే వాల్యూ ఒకటే ఉంది and 1 అనే వాల్యూ, ఓన్లీ టూ వాల్యూస్ ఉన్నాయి స్మాల్ a కామా b ప్లేస్ లో. సో therefore where a is equal to root 3 and b is equal to plus 1, then okay, so by the definition of the angle of rotation or scale factor or the noun problem, we can say that lambda is equal to a plus or minus bi are the eigen values of capital A whenever capital A is in this format. So therefore directly you can write lambda is equal to, ఎక్కడైతే మీకు స్మాల్ ఏ ఉందో దాని ప్లేస్ లో a is equal to root 3 కదా అండ్ b is equal to plus 1 కదా. సో వాల్యూ సబ్స్టిట్యూట్ చేయండి. సో therefore lambda is equal to root 3 plus or minus 1 into I. సో therefore you will get in this format eigen vectors directly. మీరు ప్రాసెస్ చేసినా కూడా మీకు అవే వాల్యూస్ వస్తాయి. క్యారెక్టరిస్టిక్ ఈక్వేషన్ అప్లై చేసి సింప్లిఫై చేసి ఒక క్వాడ్రాటిక్ ఈక్వేషన్ వస్తుంది. దానికి మీరు ఫార్ములా ఉంటుంది కదా, lambda is equal to minus b under root of plus or minus under root of b square minus 4ac by 2a. ఈ ఫార్ములా అప్లై చేసి సాల్వ్ చేసినా కూడా మీకు ఏమొచ్చేసింది అంటే lambda is equal to root 3 plus or minus I are the eigen values of the given matrix root 3 minus 1 root 3. Now for this matrix, first of all we are finding that the scale factor. The scale factor for the transformation x to ax is given by small r is equal to mod lambda. You know very well the definition of the scale factor. Length of the segment which joins that point a comma b and the origin 0 comma 0. So therefore small r is equal to det of that given complex eigenvalue root 3 under root of root 3 plus or minus small I. So small r is equal to formula under root of a square plus b square. This is the formula under root of a square plus b square. So we are applying that formula where a is equal to root 3 and b is equal to 1. So substitute the corresponding values and simplify them. You will get is small r is equal to root 4. So root 4 value is 2. So therefore small r is equal to 2. ఇక్కడ r is equal to 2 అంటే ఏమని చెప్తాం? సో ఆ స్కేల్ ఫ్యాక్టర్ ఏదైతే మనం సెగ్మెంట్ అని తీసుకుంటామో ఆరిజిన్ నుంచి మనం ఇలా లైన్ తీసుకుంటాం కదా, ఆరిజిన్ అనేది మనకు 2 యూనిట్స్ డిస్టెన్స్ లో ఉంది. ఇక్కడ స్మాల్ r is equal to మనం ఏమని చెప్తామంటే 2 యూనిట్స్ అని చెప్పేస్తాం అనమాట. సో నెక్స్ట్ ద యాంగిల్ ఆఫ్ రొటేషన్. ద యాంగిల్ ఆఫ్ రొటేషన్ ఈస్ ఫస్ట్ ప్లాట్ ద పాయింట్ A, B in the XY plane. సో ఇక్కడ మనకి ఏంటంటే మ్యాట్రిక్స్ లో క్యాపిటల్ A is equal to √3, B is equal to 1 కదా. సో విత్ ద హెల్ప్ ఆఫ్ దస్ నెంబర్స్ సో వీ కెన్ రైట్ A, B పేరుని ఎలా రాస్తామంటే √3, 1. సో ఆ √3, 1 ని మనం ఇక్కడ ఇండికేట్ చేస్తాం ర్యాండమ్ గా. ఓకే, సో దేర్ ఫోర్ సో √3 and 1 in the XY plane from the trigonometry. Okay, from the trigonometry the formula for angle of rotation phi is given as phi is equal to arc into tan B by A. So therefore phi is equal to arc into tan. Substitute that B value, B equal to 1 and A is equal to √3. B by A means 1 by √3. So tan theta lo 1 by √3 మనకి ఎప్పుడు వస్తుందో ఆ వాల్యూ మనం సబ్స్టిట్యూట్ చేసుకోవాలి. ఓకే, సో tan 30 degrees మనకు 1 by √3 కాబట్టి సో therefore 30 degrees ని మనం ఏం రాస్తామంటే రేడియన్స్ లో pi by 6 రేడియన్స్ అని రాసేస్తాం. సో therefore సో మనకు ఆ వాల్యూ సబ్స్టిట్యూట్ చేసుకుంటే 5. ఇక్కడ 5 అంటే ఏంటి మనకి we need only angle. సో ఈ యాంగిల్ ఏమని చెప్తాం అంటే మనము 30 degrees యాంగిల్. ఓకే, సో phi is equal to pi by 6 రేడియన్స్ అని చెప్పేస్తాం ఇన్ టర్మ్స్ ఆఫ్ రేడియస్. అదే మనకు డిగ్రీస్ లో అయితే మనం 30 degrees అని చెప్పేస్తాం అనమాట. బట్ బేసిక్ గా ఈ యాంగిల్ ఆఫ్ రొటేషన్ ని మనం రేడియన్స్ లోనే రిప్రజెంట్ చేయాలి ఎనీవే. ఓకే, సో therefore phi is equal to pi by 6 రేడియన్స్. సో ఈ 1 by √3 వాల్యూ ట్యాన్ లో మనకి ఏ యాంగిల్ దగ్గర రిపీట్ అవుతుందో మనం దాన్ని చూసుకోవాలి. సో దిస్ ఇస్ ద డయాగ్రామ్. ఇక్కడ మీకు ఏంటంటే x యాక్సిస్ మీద √3 వాల్యూ, ఈ హైట్ ఏంటంటే మనకు 1 యూనిట్ y యాక్సిస్ మీద. సో ఇక్కడ మీకు స్కేల్ ఫ్యాక్టర్ స్మాల్ r is equal to 2 వచ్చింది, దాన్ని కూడా మీరు ఎక్స్ప్రెస్ చేయాలి. సో XY plane. So this is the total explanation of this lecture amma. So in this lecture we have discussed about that the angle of the rotation and scale factor, problem based on the complex eigenvalues and complex eigenvectors, and problem based on the angle of rotation and scale factor. Okay, so I hope you understood this lecture very well. So in the next lecture we are coming with another lecture, another topic. So make a perfect practice, prepare well. Until bye, thank you.